In the world of programming, there are various ways to execute the code we write. These methods dictate how a computer understands and runs our instructions. We'll explore three primary methods: compilation, interpretation, and just-in-time, or JIT compilation. Each approach has its own advantages and disadvantages, influencing the speed, portability, and overall efficiency of program execution. Understanding these differences is key to grasping the nuances of programming languages and their applications. Compilation is a process where a program written in a high-level language understandable by humans is converted into a low-level language understandable by the computer's processor. This conversion happens before the program can be run. Think of it as translating a book from one language to another before someone can read it. The compilation process involves several steps. First, the code goes through pre-processing, where comments are removed and macros are expanded. Then the pre-processed code is compiled into assembly language, a low-level programming language specific to the computer's architecture. This assembly code is further assembled into machine code, the language of ones and zeros that the processor directly understands. Finally, linking combines the compiled code with necessary libraries, resulting in an executable file ready to be run. Interpretation, in contrast to compilation, translates and executes code line by line without creating an independent executable file beforehand. Imagine an interpreter as a simultaneous translator, converting and executing spoken words on the fly. Interpreted languages do not require a separate compilation step, making them platform independent. This means the same code can run on different operating systems without modification, as long as an interpreter for that language is present. However, this flexibility comes at the cost of execution speed. Since interpretation happens line by line, it can be slower, especially for complex programs with loops and repetitive tasks. Section 4. Exploring JIT compilation. JIT compilation aims to combine the best of both worlds, the speed of compiled languages and the flexibility of interpreted languages. It works by compiling parts of the code during runtime just before execution. This selective compilation targets frequently used code sections, optimizing them for faster execution. The compiled code is then stored in memory and reused for subsequent calls, improving overall performance. Languages like Java and C# employ JIT compilation to achieve a balance between portability and efficiency. Python, while primarily an interpreted language, also utilizes JIT compilation techniques in some implementations to enhance execution speed. Section 5. Python's execution model and data science prowess. Python, a versatile and popular programming language, employs an interpreted execution model. When you run a Python program, the interpreter reads and executes the code line by line, translating it into machine-understandable instructions on the fly. CPython, the reference implementation of Python, uses a combination of compilation and interpretation. It first compiles the source code into bytecode, an intermediate representation which is then executed by a virtual machine. This bytecode can be thought of as a platform-independent intermediate language that enables Python's portability. Python's popularity in data science stems from its simplicity, readability, and a rich ecosystem of libraries tailored for data analysis and manipulation. Pandas, a powerful library built on top of Python, introduces data frames, two-dimensional data structures that resemble spreadsheets. Data frames provide efficient ways to store, clean, transform, and analyze data, making them essential tools for data scientists. Python's intuitive syntax, combined with the power and ease of use of libraries like Pandas, has solidified its position as a preferred language for data science, enabling researchers and analysts to extract insights from complex datasets with relative ease.